And the mathematical mysteries goes on. There is no stop to it. Have you checked your email? Not sure. So today we can look at the new version of an area formula. For a triangle. Pretty sure that when you were young people, way back in the day, that people would walk up to you and say, "Oh, what's the area of this triangle?" And of course, I know this because we did this in term 1. And you would have eventually, after doing it many times, the area of a triangle is 1/2 the base times the height. Okay, so this question is, 1/2 times by 2 times by 4. And, whatever that number is, centimeters squared. Be looking for that. So I'm going to write the word area so don't get confused here. Now, there's something in this equation that was probably unspoken. Heights rely on right angles. So if I draw a triangle that's a bit different, this is the height in the middle here. That's where the right angle is. Or even a triangle like over here. This might be 3. And then someone would have gone along and shown you the height on the outside. So this is something that's involving a right angle. There's no right angle in the picture on the top. And there's no one's very nicely come along here and said, "Oh, this triangle is 7 centimeters high," or "this triangle is 4 centimeters high," giving me a number to put in there. However, this part of the equation takes care of that for us. Okay, so we have a new equation which sort of turns these two numbers, like this 3 and this 5, and the sin part, which is this part over here, turns this 5 into this 7 height. Okay, so that's the magic. You, of course, don't really need to know the magic. You just need to use the magic. So, taking away our little blast from the past here, let's have a look at what we do for these questions. Key issue is no right angle, no hypotenuse, okay, no adjacent side. Okay, how can I have an hypotenuse if it's opposite the right angle? And there's no right angle. So we need a new system. Because mathematicians don't have a lot of imagination, the new system is going to be called ABC. ABC. Okay, so we need to remember the following. We use capitals for points, corners. Okay, so the capitals are points, corners, vertices. And we use little letters, such as little a, as the opposite side. But you say, "Hey, there's no hypotenuse," but that's right. What's opposite this angle? Oh, and we have an angle a side over here. So this is little a. Okay, follow me here. Capital B is opposite little b. This one's confusing now because that's capital C and this is obviously little c. But, how do we tell between? Make this one bigger. So that's my new labeling system. I'm going to keep putting the labeling system again and again and again on the pictures. The book doesn't always put the labeling system on. Okay, that's the labeling system. I say opposite side is what I meant for the little letters. Okay, so with this in mind, with this labeling system, this rule, which could be written different ways because it's the side times the angle in between. The side times the side times the angle in between. This labeling system will take care of that. So area equals a half BC sine A. So it's a half times this side times whatever the angle is. In a minute, I'm going to do it with letters. We'll just finish with the fact that I could have written a similar formula because the area is the same no matter which corner you go from. So I could have written a half AB sine C. So here's the angle. side times the angle in between. And it's a half because it's a triangle. Okay, but I am always going to keep rewriting my pictures using the A as the primary corner. So I'm going to redo this example with some numbers. Okay, so that's my labeling system. Just like before, go from the start. Labeling system, right. Shazam. Wipe sesame. Okay, continuing on. Now, pretty fancy. Here we go. We've got the area of a triangle. Half base times height. No height. No right angle here. So it's time to proceed with a new therapy. Capital A. I'm going to put capital A on the live angle. The most interesting angle, I'm going to put capital A on it, but it's in the formula. So if that's capital B, capital C, little b is across from big B. Little a is across from big A. Little c is across from big C. For this question, I don't need all those sides. In fact, I can only see 3 numbers here. But let's have a look. So the area, like how many square centimeters, how many of these guys are going to fit in here, how many of them are going to fit in there, yep, area, is 1/2 times, well, B was 13, and C was 10, and this was 50 degrees. Okay, so I chose to put, this is the angle I had, that's why I chose to put my A here. So I'd have a number to put here. I don't want to remember all the different versions of the formula. I don't remember AC sine B. I just want to always put my letter in the right place so I can just remember one formula. New text is a bit smudgy. Okay, slight pause while we look for the calculators. I'm going to do 13 times 10 times sin 50. I'm going to work out that answer and then I'm going to divide it by 2. 13 times 10 times sin bracket 50. Close the bracket. And then at the end I'm going to divide by 2. Okay, that's the same as multiplying by 1/2. So we've got the answer 49. Okay, unlikely looking answer, but we're happy with that. So the area is equal to 49.8, say, centimeters squared. Seem to be in the dark section. Okay, so that's my example of finding the area of a triangle using the new rule, and in particular, the new labeling system.